Welcome to the Deep Dive, the place where we take the entire complex universe of a technology, be it architectural, strategic, or entirely new, and really just try to extract the essential, fascinating nuggets you need to be completely informed.
And today we're tackling a topic that, it really came from a simple but profound realization. The modern enterprise data landscape has become extraordinarily complex.
Oh, unbelievably so.
Yeah, I mean, if you look at the architecture diagrams from just a few years ago, it's this intimidating web of arrows, right?
Mm.
Connecting dozens of specialized products.
Right, you've got a dedicated ingestion tool over here, separate storage, a data warehouse, a data lake.
A real-time analytics cluster, and then finally, way at the end, a visualization layer.
And each of those things needs its own setup, its own complex integration. They have entirely different security models, and you need a whole team of experts just to keep the lights on.
That's exact.
And that complexity, that, high friction just to get data from point A to point Z is what Microsoft saw as this unnecessary but really predictable pattern.
And that predictable intricacy is exactly the gap that Microsoft is aiming to fill with its newest major offering, the platform known as Microsoft Fabric.
The new upstart on the block.
It really is. It's the result of them combining, decades of experience in data platforms and cloud infrastructure and wrapping it all up in a unified software as a service wrapper.
So our mission today for you listening is to get a complete high-level but also critically deep overview of this platform. We need to define what Fabric actually is, explore these foundational concepts like OneLake, which sound revolutionary,
There?
and then break down its whole ecosystem of specialized workloads. And maybe most importantly, we're going to put it head-to-head with the established giants, right? Like Databricks and Snowflake.
For sure. We have to talk about the pros and cons and where that strategic friction lies, especially when you get to that really critical issue of cost. And this isn't just about us listing features. We're going to examine Fabric's strategic identity.
Mm-hmm.
It is a unified platform that's explicitly built to reduce that management overhead, that friction.
So by putting storage, compute, and governance all under one roof, the SaaS roof, the promise is pretty clear.
The promise is that you can pivot from provisioning infrastructure to actually creating data insights. And you can do it dramatically faster than before.
That promise of speed and unification is really compelling, but it immediately raises questions for me about trade-offs, maybe vendor lock-in, which we'll definitely get to. So let's start at the very beginning. Okay, so let's unpack this, starting with that foundational shift. Fabric is a unified data analytics platform. But what does that really mean in architectural terms? What is Microsoft Fabric, and why is this move to SaaS so defining here?
So at its core, Fabric is a platform that's designed to handle the entire data lifecycle. And I mean the entire thing, from the raw ingestion of structured, unstructured data through all the advanced processing and transformation.
All the way to the final report.
All the way to the finalized reporting. Yeah. It integrates functionalities that, used to be scattered across totally independent services like Power BI, Azure Synapse Analytics, and Azure Data Factory.
And that move to a fully managed SaaS platform, that feels like the huge shift here. When we talked about Synapse or Data Factory in the past, you, the user, had significant infrastructure responsibilities.
Oh, huge. You were provisioning virtual networks, setting up storage accounts, managing security groups, scaling clusters. All of that was on you.
So what does the Fabric SaaS model take away? What does it abstract?
It abstracts away pretty much everything related to that infrastructure management plane. The user no longer worries about provisioning storage accounts or dealing with resource groups or setting up networking components.
You don't have to worry about IOPS for storage.
Nope, none of that. Fabric manages the compute capacity and the storage automatically. When you log in, you just start creating things, a lakehouse, a data flow, a SQL endpoint, and the infrastructure just spins up instantly in the background. It's all managed by Microsoft.
And that speed, that velocity is exactly what caught everyone's attention. The fact that a full end-to-end day solution, ingesting data, transforming it, viewing it in a report, was demonstrated being built in less than 5 minutes.
Yeah, that demo was pretty mind-blowing.
What used to be an hour-long session of just configuration and connecting things,
No.
it just vanishes.
And that speed is Fabric's core competitive advantage. It's this radical reduction of the time to insight. It allows for low-code interfaces for analysts and, at the same time, robust pro-code environments for engineers.
All in the same place.
All in the same place. The platform really champions this ability to build an end-to-end streaming data solution in under an hour, compared to the days, weeks, or even months that these complex multi-tool setups used to require. That operational velocity is a major strategic pillar for them.
Okay, but that speed is only really possible because the storage is also unified, right? So if Fabric is the platform, OneLake is the revolutionary architecture that underpins it. Can you explain that concept of OneLake?
Absolutely. OneLake is designed to be the single, unified data lake for the entire organization. It's built directly into the platform from the moment your Fabric tenant is provisioned.
So you never have to provision a storage account.
You never do. Think of OneLake as a tenant-wide managed file system.
Mhm.
Architecturally, it's an abstraction layer over Azure Data Lake Storage Gen 2, or ADLS Gen 2. So you get the massive scale and resilience of ADLS Gen 2.
But without all the complexity.
Exactly. It hides all the underlying complexity of managing containers and paths and security tokens.
So the whole data plane is just abstracted away. What is the strategic benefit of having one massive, pre-provisioned, centralized storage location?
The primary function is the complete elimination of data silos and, just as importantly, unnecessary data copying.
Ah, okay.
Every single workload experience within Fabric, whether you're using Spark for engineering, T-SQL for warehousing, or Power BI for visualization, uses OneLake as its native store.
Data movement is always the #1 cause of complexity and latency and cost.
It is. So
Yeah.
by making sure all the data stays in OneLake, you eliminate that friction.
That simplifies the organization-wide management dramatically. So how is the data actually organized within this single file system?
OneLake uses a really clear, logical hierarchy that kind of mirrors standard organizational structures, which makes governance a lot simpler.
Okay.
The hierarchy is tenant, which is the root of your organization's data, then workspaces, which you can align with specific business departments or projects like marketing or finance.
And then inside this?
And inside those, you create your data containers, which are known as lakehouses. This structure ensures every team gets its own curated space, but the underlying data all lives in a single governed repository.
Now, this concept of centralization, it always raises concerns about vendor lock-in, but Fabric seems to address this by standardizing on an open format. Can you tell us about the importance of Delta Lake here?
Oh, this is critical. This is absolutely critical for future-proofing and openness. Fabric standardizes data storage on the open Delta Lake format.
Which was built on Parquet.
Right, which is built on the ubiquitous Parquet file format, but it adds a transaction log layer on top. This standardization is non-negotiable inside Fabric, and it provides these essential enterprise capabilities, ACD transactions.
So atomicity, consistency, isolation, durability. The stuff you need for reliable updates.
Exactly. And you get schema enforcement to prevent bad data from getting in, and advanced features like versioning and time travel so you can do rollbacks.
Why is that standardization so powerful for me as the end user, though?
Because it means the data is fundamentally interchangeable and accessible. It's not stored in some proprietary format that's locked into Microsoft's system.
I see.
It can be read by any compute engine that understands Delta Lake or Parquet. This ensures that if you choose to use external tools for some specialized processing, your data is still accessible. That commitment to an open table format is vital for mitigating those lock-in concerns.
So the openness of the format combined with the centralized storage leads right to this core architectural principle, separation of compute from storage, and specifically enabling different skill sets to work on the same data.
Precisely. Since the data resides stably in the Delta format in OneLake, users are no longer forced into one language or one compute engine. They can access the data using the tool that's best suited for their job role.
Can you give us some concrete examples, like who is using what compute engine against that same data in OneLake?
Sure. So if you are a data engineer and you specialize in massive scale transformation, you can use the Spark engine through notebooks using languages like Python or Scala.
Okay, the classic data engineering stack.
Right. But if you are a traditional data warehouse professional or maybe a seasoned analyst, you can connect via the SQL endpoint and just use standard T-SQL.
The language they've known for 20 years.
Exactly. And then if you are dealing with log analysis or IoT streams, you can access that same data using the high-performance KQL or Kusto query language engine. The data stays put. The skill sets dictate the access method. That unification of access is revolutionary.
I want to circle back to that low-friction aspect of ingestion. If I'm a user and I have a small department file or a test data set, how does Fabric make that initial load process almost instantaneous?
This is where Fabric dramatically lowers the barrier to entry. We're moving beyond writing complex file upload scripts. Fabric supports two incredibly simple methods.
Okay.
First, there's the OneLake File Explorer. It's a Windows application that synchronizes OneLake storage locally. It lets you just drag and drop files directly into your Lakehouse folders, treating it like a standard network drive,
Like it's just another folder on my computer.
just like another folder.
Yeah.
And second, if you drag a file directly into the Fabric workspace in your web browser, the platform instantly recognizes the file type, creates the necessary metadata, and converts it into a Delta table ready for querying,
Without writing any code.
often without writing a single line of code. This capability alone just simplifies the entire ELT process right at the starting gate. It empowers business analysts who, traditionally would have to rely on IT for a simple file ingestion.
It really sounds like they focused on just eliminating all the boring boilerplate setup steps and freeing up that time for the actual analysis. So we have the unified platform, Fabric, and the unified storage, OneLake. Now let's dive into the ecosystem. The various tools or workloads that sit under this umbrella, these aren't just integrated, you're saying they are intrinsically linked.
That's exactly right. Fabric acts as a true umbrella, unifying these distinct role-specific experiences. And the crucial point is that they all share the same underlying data and governance structure.
So switching from, say, a data engineering notebook to a Power BI report is just a context switch.
It's just a context switch within the same SaaS interface. It's not a switch between different separately managed applications.
Okay, let's detail these core workloads. Let's start with data movement and preparation.
That responsibility falls to Data Factory. This is the modern cloud-native data integration layer. It handles both traditional batch data movement and complex transformation pipelines.
And it uses Power Query, which is a big deal.
It's a huge deal. It leverages the simplicity and familiarity of Power Query, which so many Power BI and Excel users already know, through what they call Data Flows Gen 2. This low-code approach gives you over 200 native connectors, allowing for a really rapid connection to diverse data sources.
From legacy on-prem databases to modern cloud services.
Everything.
Okay, so once that data is ingested and prepped, it needs some serious compute power for large-scale transformations. That's the domain of data engineering.
Right. The data engineering workload is built around Apache Spark, which is the industry standard for processing large distributed data sets. It provides managed high-performance notebooks that support Python, SQL, Scala, and R.
So this is where the pro-code data engineers live, basically.
This is their home. It allows them to create, manage, and optimize the infrastructure specifically for collecting and processing those massive data volumes sitting in OneLake.
And for those who prefer the structured environment they're used to, the traditional relational model.
For them, we use the data warehouse workload. This provides an industry-leading SQL experience, offering immense scale and performance for analytical queries.
And crucially, the warehouse is serverless and decoupled.
Exactly. It separates compute from storage, and it stores its data natively in that open Delta Lake format in OneLake. This separation means you only pay for the queries you run, while the storage remains unified and accessible to all the other Fabric workloads.
Okay, now the need for analysis on data in motion, the streaming data from IoT devices, application logs, click streams, that's growing exponentially. How is Fabric set up to handle real-time intelligence?
That falls under the real-time intelligence workload. This workload is designed for high-throughput, low-latency analysis using the KQL interface, the Kusto query language.
And that's all managed through the real-time hub.
All right, the real-time hub serves as a unified logical ingress point for all streaming data within the tenant. It manages the ingestion pipeline, it allows for stream transformations, and it stores the processed data in these high-performance KQL databases that are ready for near-instant visualization.
Then we integrate the predictive layer.
That's the data science workload. It provides the environment, the tools, the libraries you need to build, deploy, and operationalize machine learning models. It integrates tightly with external services like Azure Machine Learning for tracking experiments and registering models.
So the goal here is to easily enrich that corporate data in OneLake with predictions.
Exactly. You're turning descriptive historical analysis into predictive, forward-looking insights that are immediately accessible to business users right there in Power BI.
And that's the workload that closes the loop, the native environment for insights, Power BI.
And Power BI isn't just integrated. It's fully brought under the Fabric umbrella. It serves as the platform's native visualization layer. Since Power BI can access OneLake directly, which we'll talk about with Direct Lake mode, it ensures that business decision makers have the fastest possible access to the most recent governed data.
Okay, finally, let's address the specific mention of transactional databases as part of this ecosystem.
Yeah, so this is a nod toward integrating operational data. While Fabric is primarily an analytical platform, it does integrate with transactional services, specifically Azure SQL Database, to enable operational data storage. But the real magic happens when we transition that operational data into the analytical plane.
Which brings us to mirroring.
Which brings us to mirroring.
And that's the critical piece for enterprise adoption, right? I mean, so many organizations have massive existing data stores, operational databases, legacy data lakes that you can't just rip out and move. How does Fabric connect to that external data without forcing a massive migration project?
This is achieved via two distinct and very important features: mirroring and shortcuts.
Let's start with mirroring, which I believe is generally available now.
It is. So mirroring is Fabric's zero ETL solution for transactional data. It allows for the continuous replication of data from external operational systems. Currently, it supports SQL Server, PostgreSQL, Cosmos DB, and Azure SQL DB directly into dedicated mirror tables inside OneLake.
So this is not a nightly batch job.
Not at all. It's a near real-time continuous change data capture, or CDC, mechanism. The original data stays in the source system for operational use, but a highly synchronized, immediately queryable copy exists in OneLake for analytical consumption.
So the data engineer avoids building all those complex ETL pipelines just to get the data ready for analysts. The system just handles that replication layer automatically.
Exactly. It fundamentally changes the analytical architecture by eliminating the latency and the complexity of traditional ETL for those operational data sources. The analysts just query the mirrored tables in OneLake directly using Spark or SQL.
Okay, now, shortcuts, by contrast, they feel more like a data federation strategy. How do they work, and what is the strategic difference from mirroring?
They are fundamentally different. You're right. Mirroring copies the data continuously into OneLake.
Right.
Shortcuts never move the data. A shortcut is simply a logical pointer, a symbolic link to data that resides in an external location. And that external location could be an existing ADLS Gen 2 storage account, an S3 bucket, or soon, data in Google Cloud.
Why is that distinction so vital for enterprises?
Because it addresses the rip and replace problem. An enterprise might have 10 years of historical data stored in an existing ADLS Gen 2 lake, totally secured and governed.
They're not going to move that.
They're not moving it. But creating a shortcut, that data is instantly visible and queryable within the Fabric environment as if it were natively in OneLake, without incurring data egress costs, storage duplication, or massive migration efforts. The organization leverages their existing investment immediately. It's an evolutionary path to Fabric, not a revolutionary one.
And shortcuts also have a key internal use case for sharing data between departments, right?
Oh, absolutely. They're perfect for internal data curation and sharing. Imagine the central engineering team curates a massive, clean data set of global customer activity in their specific Lakehouse workspace.
Okay.
They can create a shortcut to this curated data and share it with the marketing and sales team workspaces. The data stays physically in the engineering workspace, controlled and governed by them, but marketing and sales can analyze it using their own dedicated compute resources without ever duplicating the files.
So that's streamlined, governed, internal data mesh enablement.
That's exactly what it is.
We've established the architecture and the ecosystem. Now let's pivot to the competitive landscape. Fabric is going head-to-head with data platform giants. We're talking Snowflake and Databricks. What are the key differentiators Fabric is leveraging to win the market? Let's start with that tactical speed advantage.
Well, Fabric's primary claim to competitive superiority really rests on three pillars: unification, speed, and native AI integration. We've talked about the speed of deployment, building a solution in an hour. This velocity is tactical because it enables this rapid iteration and departmental adoption that, even pay-as-you-go systems still require more manual configuration work to get started.
Okay, and the second strategic advantage Fabric champions is that deep integration of Power BI, which leads to this new direct lake mode. This sounds like a massive technical innovation. Let's dive into the mechanism there.
It is a huge innovation. Direct Lake Mode is designed to solve a problem that's been around forever in data visualization. Historically, Power BI used two primary connection modes: import mode,
which is very fast for queries, but the data is a copy, right? It's duplicated in the Power BI engine, which means it can get stale.
Exactly. And the other was direct query, which is real-time but can be slower because every single query has to go back and hit the underlying source.
And direct lake mode combines the best of both. So how does it technically achieve the speed of import mode while staying real-time?
It achieves this by reading the data files directly from OneLake. Specifically, it reads the Delta and Parquet files in their native format. This eliminates the need to import data into that separate Power BI modeling engine or to translate SQL queries back and forth like DirectQuery does.
So it's talking directly to the files.
It is. Power BI uses these highly optimized Parquet files within one lake that have been internally ordered using a proprietary technique called V-order. The engine essentially processes these highly structured columnar files as if they were already loaded into memory.
So you get import mode speed with DirectQuery's freshness.
That's the holy grail. And this makes Power BI a true first-class citizen in the data lake architecture.
That makes the Power BI centerpiece claim much stronger. I mean, why would you move data out of Fabric if the best-in-class visualization tool is already optimized to run natively right on it?
That's exactly their competitive argument. They're saying regardless of how efficiently competitors process the data, most business users still need it up in a visualization tool. And for many, many enterprises, that tool is Power BI. Fabric just removes that final friction point.
Beyond strategy, there are also technical optimizations, specifically around Apache Spark performance, which, has historically been plagued by startup delays.
Yeah, that optimization is the Spark acceleration feature, often called live pools. This fundamentally eliminates that traditional 5 to 10 minute wait time you'd associate with provisioning and initializing a dedicated Spark cluster. Fabric maintains these live pools of warm, ready-to-run Spark compute resources.
So what's the practical impact of having sessions start in, 9 seconds in some cases?
It dramatically shifts the data engineering workflow from this batch processing mentality to an interactive exploration mentality. Data engineers can run quick validation checks, instantly test transformation scripts, and debug interactively without that huge workflow disruption caused by lengthy startup waits.
Oh.
It just enhances developer productivity and speeds up prototyping significantly.
Okay, and here is where the conversation gets really strategic for the future. The sheer integration of artificial intelligence. Fabric is designed to be AI native.
That's a key differentiator. The AI assistance, through Copilot, is built into the fabric of the platform, not just bolted on as a standalone tool. This means AI is available across every single workload, helping not just end users, but developers and engineers too.
Can you give us some examples of Copilot's functionality across these different specialized workloads?
Sure. In Power BI, Copilot can summarize visuals for you. It can explain complex metrics. It can even write DAX measures based on natural language input. In the data engineering notebooks, it explains complex PySpark or Scala logic, helping junior developers understand legacy code or just rapidly debug. In Data Factory, it assists in building data pipelines by translating natural language expressions into pipeline logic. And, critically, for troubleshooting, it provides an intelligent summary and a root cause analysis for pipeline failures.
I found the specific AI functions available in the data science and engineering notebooks particularly intriguing because they let users apply complex AI models without having to be a machine learning expert.
These functions are tremendously powerful for rapid data enrichment. Functions like AI.translate, AI.analyze sentiment, AI.summarize, AI.classify, and AI.generate a response can be invoked in a single line of Python or SQL code right in a notebook.
So you could, for example, ingest thousands of customer support tickets.
And run AI.analyze sentiment across the entire dataset with one simple command, immediately enriching your data lake with predictive sentiment scores. It really democratizes the use of large language models for enterprise data enrichment.
Before we move to limitations, let's touch on a smaller but vital workflow improvement for analysts: in-browser modeling.
Oh, absolutely. The in-browser modeling capability streamlines the workflow significantly. Analysts can connect to the data via the SQL endpoint and create relationships between tables, define measures, and modify the underlying data model structure right inside the web browser.
So no more switching back and forth to the heavy Power BI desktop app for simple edits.
Exactly. It keeps the analyst focused on the data, not on tool management.
Now, we have to adopt a critical lens here. This all sounds excellent, but the competitors are not standing still, and they have some very valid counter-arguments. What are their direct responses to Fabric's strengths?
Well, the primary response from competitors is to challenge that reliance on Power BI. Databricks launched Lakeview to provide native dashboarding capabilities directly on their lakehouse. And Snowflake acquired Streamlit to accelerate their push for a Python-based environment for developing custom dashboards.
So they're both trying to build their own end-to-end platform that includes the visualization layer to neutralize that Power BI advantage.
They are, aggressively.
Okay, let's discuss the acknowledged limitations that the competition frequently highlights, starting with data lineage and governance granularity.
Data lineage is a common point of competitive friction. While Fabric integrates Purview for governance and provides item-level lineage, so you can see which reports use which lakehouses. It currently lacks the granular column-level lineage that's offered by competitors like Databricks Unity Catalog.
And for highly regulated industries, that's a big deal. They need to see exactly how a specific column value propagated through the entire pipeline.
It is a big deal. Fabric is still maturing in that specific dimension.
And now the most important strategic hurdle, I think, for large-scale enterprise adoption, the cost model difference. This is complex and crucial.
This is perhaps the biggest strategic difference between Fabric and its main competitors. Databricks and Snowflake primarily operate on a highly flexible, highly granular, pay-for-consumption model. You pay only for the compute resources you use down to the second, which is excellent for highly unpredictable or sporadic workloads.
And how does Fabric's model contrast with that?
Fabric uses a capacity planning model, which is centered around the Fabric Capacity Unit, or CU. Users pre-purchase a fixed block of compute capacity, typically on a reserved basis. This capacity is then shared across all the workloads: Spark, SQL, KQL, Power BI within the tenant.
Which offers predictable spending. You know exactly what your bill is going to be.
It is. You know exactly what your platform costs per month.
But what is the strategic downside of that capacity model, especially when you're facing unpredictable demand?
The key strategic downside is the risk of inefficiency. If your usage is consistently low, you have wasted unused capacity that you've already paid for.
Right.
Conversely, if demand spikes unexpectedly, Fabric capacity can experience throttling. When the platform determines the demand exceeds the purchased CUs, it will slow down or queue queries to ensure service stability.
And that can negatively impact performance during peak business hours.
It absolutely can. This means organizations have to invest significant effort into capacity planning and forecasting, which is a complexity that the consumption model just avoids.
So the organization is trading the cost predictability of the capacity model for the flexibility and high-scale performance of the consumption model, where unpredictable surges are just instantly met by paying a higher price. That is a critical architectural choice that goes way beyond just features. Let's move into the essential layer of governance, which is often the silent deciding factor for enterprise IT adoption. The unification of Fabric must simplify the governance story significantly compared to managing, 5 different services.
Oh, it absolutely does. Centralized management and governance are unified across the entire Fabric tenant, and it's powered by a built-in version of Purview.
So what does that integration actually mean in practice?
It means that when data is ingested, permissions, access controls, and data sensitivity labels are automatically applied and then inherited across all the associated items. From the underlying Delta files in OneLake, all the way up through the notebooks, the SQL endpoint, and the final Power BI report.
So you're eliminating that manual synchronization of security policies across a bunch of disparate services.
Exactly.
We've also seen some critical security enhancements recently, focusing on encryption and auditing, which are vital for regulated industries.
Indeed. For robust security features, workspace administrators recently gained the ability to configure encryption using customer-managed keys, or CMK, at the workspace level.
Which means the customer retains complete control over the encryption keys used to protect their sensitive content.
That's right. It lets them meet some really stringent regulatory requirements.
And what about auditing? Compliance teams need detailed, immutable records of data access and changes.
Auditing for Fabric SQL databases is now granularly managed. Administrators can set up detailed auditing at the database level. They can configure retention periods up to 35 days and use these sophisticated predicate expressions to filter logs based on specific user groups, actions, or sensitive tables.
And where are these critical audit logs stored? And what ensures their integrity?
Critically, these logs are stored immutably in a read-only audit folder right inside OneLake. Because that location is managed and designated as immutable, it satisfies many compliance needs by ensuring the logs cannot be tampered with after they are written. It provides verifiable proof of access and activity.
That seems like a perfect example of how OneLake enables better governance. So how is file-level access handled for specific users while maintaining that centralized security framework?
That's handled through enhanced OneLake security coupled with row-level security, or RLS. New read-write permissions now allow for really fine-grained access control. For example, you can grant a specific user permission to write files to only one designated folder within a lakehouse.
Like a specific sales region's data drop zone.
Exactly. Without granting them elevated administrative access to the entire workspace, that separation of duties is essential for large teams.
Okay, let's pivot to features specifically designed to win over traditional data warehouse professionals, the ones who rely on optimized SQL performance. Let's start with query optimization features like data clustering.
So data clustering is a feature that leverages the physical structure of the Parquet files within Delta Lake. It intelligently arranges the data in storage based on specified clustering keys. These are typically columns that are frequently used in where clauses like dates or customer IDs.
And how does that physical arrangement translate into those massive performance gains we saw demonstrated? A drop from over 40 seconds down to just 1 second.
The mechanism relies on skipping irrelevant files. When data is clustered, the engine stores min-max statistics for the data held within each physical file. So when a user runs a query, say, select everything where the date is June 15th, 2024, the query engine checks the min-max statistics for all the files. If a file's date range doesn't include that date, the engine just skips reading that file entirely.
It just skips it.
It skips it. This selective reading dramatically reduces the amount of data that has to be processed, leading to near instantaneous query results on heavily partitioned data.
That's a sophisticated optimization. What about key management in large analytical models? That often requires surrogate keys.
That's handled by the introduction of identity columns. For analytical warehouses, surrogate keys, these unique numeric identifiers, are essential for maintaining relationships in the model. Identity columns automatically generate unique, monotonically increasing numeric values for new rows that are inserted into a table.
So it simplifies surrogate key management in a distributed environment.
It does, and it ensures data integrity and uniqueness without requiring the data engineer to write complex sequence generation logic.
Data consistency during frequent ETL operations is always a challenge. If an analyst runs a complex report that takes an hour, they need to know that the underlying data won't change halfway through.
That's the exact problem solved by warehouse snapshots. This feature allows analysts to access a consistent, static, point-in-time view of the warehouse.
So the data engineers can create a snapshot before they start a lengthy ETL job.
Exactly. The analyst queries the snapshot, which remains consistent for the entire duration of their analysis, even as the live data is being updated. Once the ETL job completes successfully, the snapshot can be rolled forward to represent the new, latest consistent state, and it's seamless.
And what safety net is built in for the database itself?
Automated backups are built in for the SQL database component, providing essential disaster recovery capabilities. These backups have configurable retention periods, usually 1 to 35 days, and they support point-in-time restore capabilities.
So it eliminates the need for users to manually configure complex backup strategies in Azure.
Right. It shifts that entire burden to the managed service.
Finally, let's wrap up this section by focusing on developer productivity and tooling integration, which often determines engineer satisfaction.
Yeah, developer productivity is heavily enhanced by cross-tool access. Fabric addresses the hassle of managing countless connection strings. Developers can copy a single SQL connection string from the Fabric workspace and use it to connect standard client tools.
Like Azure Data Studio or SSMS.
Right, the tools they know and trust, to any database, lakehouse, or warehouse inside that workspace. They just connect instantly.
And for monitoring and debugging complex data flows, how does Copilot assist the engineer?
The Error Insights Copilot and the Improved Monitoring Hub work hand in hand. When a data factory pipeline fails, Copilot provides an intelligence summary, a likely root cause analysis, and suggested remediation steps. It groups all those complex cryptic error logs into actionable insights.
And the monitoring hub.
The monitoring hub provides a critical hierarchical view, which lets engineers track the status of upstream and downstream job runs across multiple pipeline activities. This is essential for understanding dependency failures in complex data graphs.
We've covered a tremendous amount of ground today, from the fundamental architectural shift to SaaS and OneLake, through the vast array of specialized integrated workloads, right down to the specific competitive advantages and advanced governance features.
To summarize Fabric's core value proposition, it's really built to dramatically reduce the complexity and organizational friction that's inherent in traditional architectures. It unifies data storage with OneLake, it standardizes compute access across Spark, T-SQL, and KQL, and it embeds intelligence everywhere with Copilot.
So the strategic goal is moving from months of infrastructure setup to hours of solution delivery.
That's the goal.
The platform positions itself as this unavoidable central hub, the single location where all enterprise data comes to live, and where actionable insights, natively optimized by Power BI's Direct Lake mode, are derived. It really directly challenges the narrative that data must remain siloed in specialized data warehouses or separate data lakes.
However, this incredible speed and low barrier to entry, the fact that a full end-to-end data solution could be built in under an hour without deep, specialized engineering expertise, it raises a really critical organizational question for you, the learner.
Right. If the technical barriers disappear, how will that fundamentally change who in the organization is responsible for building, certifying, and governing these enterprise-grade data platforms?
Exactly.
If the departmental analyst can spin up a lakehouse in 5 minutes, does data governance decentralize away from central IT, or does it actually require IT to apply even stricter controls and oversight over the entire tenant? That shift in responsibility is what organizations have to manage next.
And on a technical note, we'd encourage you to deeply investigate the trade-offs of the Fabric Capacity Planning model. Understanding the exact cost implications of capacity units, how much you buy, how much you risk wasting, and the potential impact of throttling during peak loads is vital when you're contrasting it with the operational agility of pay-as-you-go consumption models from competitors.
That cost model difference is often the defining factor for strategic long-term adoption.
It really is.
Until next time, keep digging into the data and challenging the status quo.